Welcome to day 3, Honors Algebra 2. We are in 1-4 and 1-6, absolute value equations and inequalities. It says, what does it mean to find the absolute value of a number? It means to find a number's distance away from 0. So absolute value is a number's distance away from 0 on the number line. Okay, so what does it mean if the absolute value of x is 4? So they're saying the distance from 0 to this number x is 4. So if you were to look at a number line and you have 0, what number gives you a distance? When you see these bars, it's saying the bars equal 4, the distance equals 4. Therefore, I could have been the number 4, or it could have been the number -4. So that means x, the stuff inside, could have been 4, or it could have been -4. So if your distance is a, then you could have been a or -a. In mathematics, we define things by using letters to represent numbers, because maybe it works for 4, but does it work for 5? Does it work for 6? Well, it's better to use a variable that represents all the numbers that are greater than 0. So that's why we say a. Example 1, it says solve for this equation. So my distance is 9. If my distance is 9, that means I could have been the number 9. I could have been the number 9, or I could have been the number -9. Therefore, the stuff inside has to equal 9, or it has to equal -9. We have two directions, therefore, we will always have two equations. That is not true. -9 plus 6 is a -3. I apologize. So that means if I was 15 and I removed 6, I am 9. Yeah, that's a distance of 9. If I was -3 and I removed 6, that's -9, which is a distance of 9. Yes, they work. Here, we said whatever's inside equals the distance of what exists, or the negation of that. So when I go to solve, I'm going to get -2x minus 3 equals 5. So go ahead and continue to solve these. Pause it if you need to. So you're always going to have two equations, one being positive and one being negative, because they're two different directions. Now it says check your solutions. And they really want you to check your solutions when you're equaling a variable, because here's the thing. If you get a negative answer, it's not necessarily wrong. But if I put a negative back into my original equation, hopefully it doesn't become negative, because we're talking about distance here. So if I substitute a -4 back in to the original equation, we're going to get absolute value of -7 equals -12 plus 5. Absolute value of -7 equals -7. Absolute value of -7 is 7. That is not true. So -4 doesn't work, because when it has different properties when we solved it without absolute values versus the properties of having absolute values. So we received an algebraic answer, but it doesn't work when you substitute it back in. So this is called an extraneous solution. You don't have to say that, but that's what this is. Think of it like an extra solution. So let's see if this solution works. If both of these don't work, then we have no solution. It just doesn't satisfy the properties. So if I go back to my original equation and I put -1/2 in, I'm going to get -3.5 absolute value, -3/2 plus 5. absolute value of negative 3.5 equals negative 3. 10, and you can just use your calculator if you can't convert, but I encourage you to convert as much as you can in your head. So when you get to higher math, it won't be as difficult. And it works. If you want to pause that or rewind it and copy it down, take a minute to think about it. Well, if I wanted a denominator of 2, I make a denominator of 2 and I say, okay, 5 times 2, 10. So this solution worked because the negative answer was very small, so it didn't make our overall distance negative. Here, my distance is 21, you might say, but there's this 9 and the 4 in the way, so we have to remove those. The 9 is the furthest thing away, or orders of operation backwards. So subtraction, addition come first, and then division. You do not want to bring 4 in. These absolute value bars stay by themselves. So if your distance is 3, then you would just set it up like normal. So your answer is 5 and 1. And some people make their answers like this. It's not a coordinate the way these brackets are. That is fine as well as a solution set. I'm pretty lenient. All right. This one says practice, then check your solutions. So I'm going to give you, I want you to pause. I want you to try doing the next 5. All right. Number 1, immediately, if you come back, the absolute value is negative 7. It's saying your distance from 0 to whatever is negative 7. Well, you can't have a distance of negative, so no solution. Or if you would have done it algebraically and substituted your answers back in, it just wouldn't have worked. Here, you're equal to x plus 5 and negative x minus 5. These are your solutions. They work. If you would have solved for the positive and the negative, you would have gotten negative 4 equals 1. These would have canceled, which is not true, so you can't use that. So this would be your solution. Like I said, pause if you need to. Check your work, make sure it makes sense. If you didn't do the back, pause now and do it. All right, once again, we have to get the absolute value bars by themselves, so subtract 3. And then now you can set up your 2 equations from here. So 2u minus 1 equals 3, 2u minus 1 equals negative 3, and then solve. And here, you have to get this by itself. Well, I'm sorry, the absolute value bars by themselves. So remove the positive 7 by subtracting, and you will get a negative 3. Then from this equation on, divide both sides by negative 3. This is your equation. So you're going to set up, it should be positive 1. 4d minus 7 equals 1. 4d minus 7 equals negative 1. And then you would have gotten your 2 solutions. Okay. If you need to pause on a separate sheet of paper, try it again, that's fine. All right, second part is the absolute value inequalities. Now we're saying our distance is less than 4. So if you have a distance less than 4, think about that. You would be the numbers 1, 2, 3, and other numbers too, but you'd be less than the number 4. So x could be less than 4. If you wanted a distance of 1, 2, 3 less than 4, you could have been negative 3, negative 2, and negative 1. Those numbers are actually greater than negative 4. So when you are less than 4, you're less than 4 or greater than negative 4. So when you're less than a, then x is less than a, or x is greater than negative a. Because the direction changes on the number line, your direction changes with your inequalities. Same thing here. If I want a distance that's greater than 4, such as 5, the number 5 is greater than 4, so that value would be greater than 4. But if you wanted a distance of greater than 4 this way, you might be like the number negative 5. Well, the number negative 5 is actually less than negative 4. So once again, since the direction changes, so does your sign. So if you want to be greater than a, you can be, or you could have that value inside the absolute value bars be less than the negative of that. So you set up your 2 equations just like you normally do. 2y plus 9 would be less than 13, but if you flip it the other way, your sign changes and you get 2y plus 9 is greater than negative 13. If you're like, I get how to do this, you just flip the sign and negate, but it's not making sense, rewind and go back up here. Think about it. Okay, so we're going to subtract 9. Divide. So we have to be greater than negative 11 and less than 2. It doesn't say to graph, so that's fine. Here, we need to get rid of this negative, so we have to divide, but remember, when we divide, the sign flips. So 4 minus x is less than or equal to 5, and 4 minus x is greater than or equal to negative 5. Flip the sign. Flip the sign. I have to be less than 9, but I have to be greater than negative 1. Okay? All right, I want you to do these next 3 on your own. Pause the video, and then watch for your answers. We have to flip the sign. I'm going to rewrite this one, so I'm just going to rewrite all these. I'm going to rewrite this one by removing 6 first. Okay, then you set up your 2 equations. Okay, so this one, we got r is less than 5 and r is greater than 3. Okay, then the next one, we have, okay, why is this not going in focus? There we go. We have u is greater than 3, and we have u is less than 1/2. Well, I can't be greater than 3 and less than 1/2, so it's an or statement. Okay, and you can try it if you're not sure. You could try a number greater than 3, you could try a number less than 1/2 and make sure that they work. So number less than 1/2 is 0. If I put 0 in here, that'll work. If I try a number that's greater than 3, 10, 40, yep, that will work. Okay, here it's saying I have to be greater than or equal to 1/2, but I have to be less than or equal to 1/2. So a number less than 1/2 would be 0. If I put 0 in here, that wouldn't work. Let's see. Well, 0 would work. And then this one says, if we put 1/2, if I put 1/2 in here, I get 1. 1 minus 3 is -2. Obviously, the value of -2 is 2, so that'd be 10, that'd be 16. That would work. So 1/2 works. A number less than 1/2 works. What's a number greater than 1/2? Let's try 10. 10, so it'd be 20 minus 3 is 17. 17 times 5 is a big number. All of them would work. So if I have to be greater than or equal to 1/2, or I have to be less than or equal to 1/2, then it would just be all real numbers work. Any number will work in here. Well, think about it. If you're greater than a negative, you just have to be greater than 0, or in that -4. So any number you put in here is going to be the absolute value, and then add it to 6. Any number is going to work. Okay. All right. This is your notes for the following day. You are done with that. Your checking for understanding was throughout your notes. So now at this time, you're just going to do your book work. Your bell ringer that you have That 1.7, we'll just check it in class. And tomorrow when you come in, we're going to go over 3 homework assignments. So be ready. Star those things that you had questions on.